so hopefully the sound's going to be loud enough. Oh, it's not. Here, hold on. Just a little bit farther. Okay, so 6.5, we're going to talk about simplifying complex fractions. So first off, what is a complex fraction? Well, it's when you have fractions within fractions. So fractions within fractions. And there are two separate methods for simplifying these, but typically students like one over the other. You can choose whichever one you prefer. I will point out the one that most of my students tend to gravitate towards, which, by the way, is not my way. So this first one is actually my way. So option one is we identify the lowest common denominator of all of the quote-unquote little fractions. Okay? And then what we're going to do is we're going to multiply the big top and the big bottom by that LCD that we find in the top. Okay, what this is going to do, it's going to cancel all the little bottoms. Because we choose it, right? We choose what we're going to multiply by just for that to happen. Okay. When we multiply, it's going to distribute, right? If we have more than one fraction in the top or bottom. More than one. There we go. One fraction. I'm trying to hurry. I don't need to hurry. Fraction in the top or bottom. We'll see examples of that here in just a second. And then simplify if possible. Okay, so let's do our first example. So, right, I have fractions within this big fraction, right? So here's my big fraction line. This is the big top and the big bottom. So here are my little denominators, right? 7, 3, 6, 14. I need to find the LCD of those four numbers. Right? I need the smallest thing that all of them will go into. So I'm just going to go ahead and grab the biggest number I have there and just start building it. So I know I need a 14, right? I need a 7, but the 7 goes into 14, so I don't need something extra for that. I need a 6. So 6 has a factor of 2, which I get with my 14. But then I also need a factor of 3, right? So that 6 is there. Let me write this 14 as 2 times 7, okay? And then there's my 3, so there's my 6. There's the 7, and there's the 3. So it looks like this is going to be my LCD, whatever 14 times 3 is. 12, you're the one, 42. Okay. So what we're going to do then is I'm going to wrap parentheses around the big top because it has 2 terms, and around the big bottom it has 2 terms. And then I'm going to multiply the big top by 42, and I'll stick a 1 under it because I know students like that. And then I'm going to multiply the big bottom also by 42. So just like before, so I'm going to grab this orange marker, it might be too much. This right here, this 42 over 1 over 42 over 1, that's actually 1. I have the exact same thing in the top as I have in the bottom, so multiplying by that does not change the value. Okay. So now on the top, the 42 over 1 multiplies in. I'm going to do a little gory detail here. So I'm going to have 2 over 7 times 42 over 1. Okay. And then plus 1/3 times 42 over 1. Just kind of focusing here on the big top, right? The 7 and the 42, cancel, cancel, leaves behind a 6. The 3 and the 42, leaves behind a 14. There it is right there. Click back up. Okay, so now my new big top, my new non-denominator big top, I'll put it down here because I'm kind of running out of room. Make sure that's still on my screen. I've got 2 times 6. Are you still with me? And then plus, right, that's this plus right there, 1 times 14. Okay, so now let's go back and get the big bottom. So the 42 again is going to distribute. So I have the 5/6 that started there, but then it gets multiplied by the 42 over 1 minus 1/14 I started with times 42 over 1. And then reduce. So the 6 goes into the 42, 7. 5 times 7 is left, so that's a 35 to start with. Minus And then the 42 and the 14, when they cancel, it leaves behind 3. Okay, so now we're going to do that math. So I have 12 plus 14 over 35 minus 3. I just didn't do that multiplying before. What's that, 32? So that's 26 over 32, which is a great answer, good answer. But then we could also reduce because now I know 2 goes into everybody. So I could divide everybody by 2, and then that looks like that'll be 13 over 16. Okay, so this fraction we started with is equivalent to 13/16 because the only thing we did was multiply by this ugly version of 1. Okay, so now we're going to go ahead and up the ante and put some x's in there because that's what we do. So let's see if I can fit my LCD over here. So I need a 5x. I need an x squared. I've got 1. That means I just need to do a squared on my x, so it's taken care of. I need a 5, which I have. And I need a factor of 2 and an x. So the x is good, but I do need another 2 as a factor. So I'll go ahead and multiply by 2. So my LCD is going to be 10x squared. Okay, so here we go. Big top by 10x squared over 1 if you'd like. Big bottom by 10x squared over 1 if you'd like. Distribute both the top and the bottom. And again, if you want to write it out, I'm going to go ahead and skip that step because some people might like that better, just so you see what that looks like. So when the 10x multiplies this first one, right, I'm going to have the 6 that's left, or that I started with. But then the 5x, when it goes into 10x squared, it leaves behind a times 2x, right? Because the 5 goes into the 10, leaves behind a 2. The x goes into the x squared, leaves behind an x. Okay? So now I'm at the minus sign. 2 over x squared times 10 over x squareds. This time the whole x squares would cancel, and I have 2 times 10. Okay. Coming down to the bottom, again, the 10x squared multiplies in, so I'll cancel the 5. Leave behind a 2x squared to multiply that x. 2x cubed plus in the middle, and then right here I have 2x on the bottom, 10x on the top, so that'll be a 5, and the x and the x squared, right, those will cancel, leave behind an x to the first. Okay, so now we're just going to tidy. So 6 times 2 times x is 12x, minus 2 times 10 is 20, and then on the bottom, that's already tidied, 2x cubed plus 5x. Now this is as simple as it gets. Even though 3 of my terms have x's, there's one that doesn't, which means it's not a factor, which means we can't take it out. Okay, so that's the way that I usually do it, but my students don't, so now I'll show you what you'll probably end up doing. Okay, so option 2, what you're going to do is you're going to add the fractions together that are on the top and add the fractions together that are on the bottom. And then we're going to use that, flip the bottom and multiply. So remember when this is step 2, right? If I have a over b over, that's right, divided by c over d, the way we can rewrite that is the top times the reciprocal of the bottom. That was supposed to be a d. A little dyslexia going on, sorry about that. Okay, flip the bottom, it's a reciprocal, and then times. So flip the bottom and multiply, simplify if possible. Okay, so if I want to add the two fractions though, right, so let's say I want to add 3 over x minus 1/2. To add those two fractions, what do we need? Common denominator. So it looks like it'll be a 2x. So the first fraction, it has the x, it needs the 2. So we're going to multiply top and bottom of that fraction by 2. So how this is different is that I just multiply by 1. I multiply each of the individual fractions by their own version of 1, right, to come up with the common denominator I need just for the big top, and then a common denominator for just the big bottom. Okay. So there, my common denominator is going to be 2x, so what? I have 6. And then on the 1/2, right, it's trying to get to 2x, so it needs an x on the bottom, which means it needs an x on the top for balance. So I have 6 minus x. Oh gosh, I totally did that so fast. I am so sorry. I got distracted with my whole reciprocal idea. So the extra step that was in there was 6 over x minus x over, 6 over 2x minus x over 2x leads me to 6 minus x over 2x. Sorry, I did that so fast. Okay, so slower on the bottom. On the bottom, common denominator between 4 and 6 looks like it'll be 12. So first fraction, 3 top and bottom. So that one will be 3x over 12. Here, I'll force myself to take it slow. Plus, so to get from 6 to 12, I'm going to multiply by 2, top by 2, bottom by 2. So then I'll get 6x over 12. And then if I combine those, so now those have the same denominator. Looks like I've got 9x over 12. Okay. So now one fraction on the bottom, one fraction on the top. We're going to take that bottom, flip, and multiply. So I'm going to have 6 minus x over 2x times, so the reciprocal. So the 12 is going to go on top, the 9x on the bottom. And now before I finish, I'm going to go ahead and simplify. So the 2 can go into the 12. It can't go into the 6 because that 6 got the minus x going on, so I can't do that. But the 6 into the 12 leaves behind a 6. Okay, same thing here. The x's can't go because this is a 6 minus x. But I can do the 9 and the 6. I can get rid of a 3 out of these guys because they're all multiplying. They don't have a plus or a minus attached to them. So the 3 into the 6 leaves behind a 2 and leaves behind a 3. Okay, let's gather up what we've got. I've got a 6 minus x. Now that's kind of has some parentheses around it because it's that whole business there. And then that multiplies by 2. It was on the left. I'm sorry, it was on the right. I moved it to the left. It's just kind of convenient, conventional. And then I've got a 3 left here and an x times an x. And x times x is x squared. So this is a great answer, or you could distribute that 2 in the top to get 12 minus 2x over 3x squared. Now, do not go any farther. There's nothing else you can do. Nothing can be canceled. You can't combine anything else because nobody else is like, so you have to stop there. Okay, last one. Common denominator, so for the top, looks like it'll be xy. Okay, so 1 over x needs a y top and bottom. So we'll have y over x plus, second fraction on the top. Again, we're looking for xy for that denominator, so I can add the two fractions. So x top and bottom. Oh, goodness sakes, thank you so much, whoever was hollering that at me. So first fraction, y over y times x, I switched them, plus x over y times x, I switched them. Same thing on the bottom. X times y is our common denominator, so x, y. So that one will be x squared over xy minus y squared over xy. Okay, take a step to combine the two fractions in the top. So x plus y, again, I'm just kind of getting ready for it, so I went ahead and switched the order of my addition to be x plus y. Addition, it doesn't matter. Subtraction, it does, so I can't be swapping the x squared and the y squared. It has to be x squared minus y squared. But multiplication and addition, you can change the order. Okay, one fraction over another fraction, and just one. So the bottom flips and multiplies. So here's the top as is. Here's the multiply instead of the divide, right? This is the flip and multiply. So this division is now that multiplication. So here's the fraction from the bottom. It flips. And we multiply. So the reciprocal. Okay, so the x times y, top and bottom, we can get rid of those guys. And it gets us to here. I'm going to take an extra step. X plus y over x squared minus y squared. This is a good answer. To get to the great answer, what we need to do, because we've done our factoring section, is factor that denominator. So it's x squared minus y squared, so difference of squares. Okay. It doesn't often happen, but sometimes it will. So now we're going to cancel those x plus y's. Now, I want you to think about what got left behind where before you write down your answer. Okay. When you cancel all of a factor from the numerator, right, that leaves behind a 1 in the numerator. So my equivalent answer is going to be 1 over x minus y. All right, good luck with your complex fractions.